Hello. So the second half of 11.1 starts with limits to infinity. When we're talking about limits to infinity, you want to think about the horizontal asymptote. Okay. So when you're looking at a polynomial and the degree on the top is equal to the degree on the bottom, reduce the two largest degree terms. So you just reduce the two largest degree terms. If we look at a couple examples. 43, 44. Limit as x goes to infinity, 3x over x minus 1. When we're looking at the degree is the largest exponent on your term. So in the top, 3x, the degree would be 1. On the bottom, x is to the first power also, so the degree is 1. When the degrees are the same, you just reduce those two terms. 3x over x, our answer is 3. Limit as x goes to negative infinity. 3x squared plus 2x over 2x squared minus 2x plus 1. Notice the degree on the top is 2, and the degree on the bottom is also 2. That makes it worse. There we go. Oh, much better. So the degree on the top was 2, because that's your largest exponent, and on the bottom also 2. When the degree on the top and the bottom is the same, you use the two largest degree terms. 3x squared over 2x squared is 3/2. Because when your number is getting that large, these other values don't mean anything. Try one more. And notice this one was negative infinity. It wouldn't matter if it was positive or negative. You would still get the value. You don't have to worry about the sign. When we were graphing these, also when this would happen, that would find our horizontal asymptotes. Degree on bottom is larger. If the degree on the bottom is larger, that means the bottom is getting larger faster, and this will go to 0 then. So if the degree on the bottom is larger, limit equals 0. 47. Limit as x goes to infinity, 3x cubed plus 6x minus 9 over x to the 4th plus 2. So degree on the top, 3. The degree on the bottom, 4. because degree in the denominator is greater than the degree in the numerator, our answer is 0. Try one more. Okay. 2x plus 5 over x cubed minus 6. The degree on the top is 1. The degree on the bottom is 3. When the bottom is larger, this is going to grow so much faster, it equals 0. I guess you can figure out what the next one is. It's when the degree on the top is larger. Well, when the degree on the top is larger, that means it's going to get very large very fast. So it's going to get huge. The limit does not exist. It's getting close to positive or negative infinity. And just like we did earlier, to find out that, you can graph it. But it will still require you to say does not exist, and then if it's going to positive or negative infinity. So if we had this, we know the degree on the top is 4, and the degree on the bottom is 2. That tells us that the limit does not exist. And that's because it's getting huge. So we want to know if it's positive or negative infinity. One way to do that is to graph it. So if we plug that in, delete what I have there. Delete, clear. X to the 4th minus x to the 3rd minus 3x divided by, make sure you're putting your numerator and denominator in parentheses, unless you have a fraction bar. Make sure I have it right. X. Okay. So then we graph it. Well, let's see what my window is. I think it'll work. I have negative 10, 10, negative 10, 10. Okay. And we were looking at what positive. So we're looking for positive infinity, which means we're going this way. And notice it's increasing. So it's going to positive infinity. So it does not exist and positive infinity. Look at one more. Limit as x approaches infinity. Negative 5x cubed minus 4x squared plus 8 over 6x squared plus 3x plus 2. Degree on the top is 3. Degree on the bottom is 2. since the degree on the top is larger, it does not have a limit because it's getting huge. Then we need to graph it. So clear what I have. Negative 5x cubed. Make sure when you're doing a negative, you hit the negative and not the minus. Forgot my parenthesis. So negative 5x cubed minus 4x squared plus 8 divided by 6x squared plus 3x plus 2. Right. And then we hit graph. On this one, we were looking for positive infinity also. Notice for positive infinities, this is getting large, y is getting negatively large. So limit doesn't exist because it's getting negatively large. So that would be limits to infinity. The last part in this section is the average of a function. When we're talking about the average of a function, usually when we talk about average, we divide by the total amount. And in this case, our total is x. So if we have a function f of x, the average, they put a line over it for average, the bar on top of the f means average. And you take your function and you divide by x. Another thing you can do, if your function is a fraction, you could, instead of dividing by x, you could multiply by 1 over x. So either case, if it's a polynomial, I use this one. If it's a fraction, this one. So let's look at a problem. Number 85. Okay, so this one here, it says the cost in dollars for manufacture a particular DVD is C of x equals 15,000 plus 6x, where x is the number of DVDs produced. Recall from previous chapter that the average cost per DVD, and this was in chapter 10, I think, is found by dividing by x. So we have this problem, and it says to find the average, and then find the limit to infinity and interpret it. So to find the average cost, we take the function 15,000 plus 6x and we divide by x. And this is the average cost function. So if we plugged in x, it tells us what it would cost per unit rather than total cost. It says find and interpret the limit as x goes to infinity. So the limit of 15,000 plus 6x over x. Well, first of all, remember when we're doing limits to infinity, we find the degree of the top and the bottom. And the degree on the top, this is our largest exponent, is 1. And the degree on the bottom is also 1. When they are the same, we take the two largest degree terms, 6x over x, and reduce it and get 6. So the limit as x approaches infinity is 6. Now we need to explain that. Well, we know that C of x is cost in dollars. X is the number of DVDs produced. So as x becomes extremely large, as x, which is the number of DVDs, so as the number of DVDs produced becomes extremely large, the cost approaches $6 per DVD. So instead of the total cost, it's giving you how much is per DVD. Number 86. In Chapter 1, we saw the cost to fly X miles on American Airlines could be approximated by this equation. So C of X is cost, and X is miles flown. And we want to find average cost, and then interpret the limit as X approaches infinity. So first thing, find the another sheet. So average cost, C of x, so C bar of x equals, take your function, 0.0738x plus 111.83 and divide by x. Again, we look at the degree of the top and bottom, and notice they're both the same. They're both to the first power. So it's going to approach this. And the x's will cancel. We get this. This is in dollars because the cost was in dollars. So this would be approximately 7 cents. Oops, I did the limit at the same time. So this is the limit infinity. So as we're looking at the limit getting large, and that's your x value. The x value was miles flown. After many hours, many flyer hours, many frequent flyer hours. The cost to fly is 7 cents per mile. So you take your x value and it gets large, extremely large, several, well not several, more than several, but extremely large, many, huge, something big for your x values. It approaches the y value, and that's per item. So 7 cents per mile. That's everything in section 11.1.